of their population.
Hello, everyone. My name is Amir I'm a research fellow at Harvard Med School, and my talk today is about sleep, which is a bit ironic considering it's the afternoon session right after everyone had lunch. So background, restful and adequate sleep is very important to everyone's health and well-being, but especially in the older adult population. We know from many lab-based studies that ambient temperature and changes in ambient temperature can have a causal effect on sleep. And also from studies within environments that humans are not particularly shielded from the outside weather. However, we do not know whether and to what extent the sleep in older adults who live in a modern built environment with modern buildings and their heating and cooling systems is impacted by their bedroom ambient temperature, which is supposedly selected and controlled by them. And it's important to understand this link because it can be a point of intervention to help improve sleep within this population. So our hypothesis is that there exists a relationship, a link between ambient temperature and outcomes related to quality and duration of sleep within older adults, and that these links are independent from other relevant factors that may influence sleep. And also, we hypothesize that these relationships vary between persons. And I'll show you what we mean by that in a few slides. So this is, we use the data that we collected under the Home Environment Health Study in Marcus Institute for Aging Research. It was a longitudinal observational study that we had for about a year and a half. And we monitored ambient temperature, bedroom ambient temperature that is, and variable measured sleep. And you can see the kind of the inclusion-exclusion criteria. And the ethics of this project were approved by Advera IRB. So we measured indoor temperature and relative humidity using this net atmos sensor. We had 2 of these in each home, in each bedroom. And then we used Oura Ring, the wearable device that you see here. It's worn on the finger to measure sleep efficiency, which is the ratio of time spent sleep to time spent in bed. And this is our primary outcome. This is our most important outcome, as well as total sleep time and sleep restlessness, which is the average number of movements per hours of sleep. And here's our conceptual model. So we assumed between on the left and within subjects variations in the outcome. And we tried to, we investigated the link between nighttime ambient temperature, our predictor variable, and sleep, so the kind of the red arrow here, while adjusting for and accounting for all these other between and within subject or between individual sources of variation. What we did was to average the nighttime indoor temperature and humidity between the hours of midnight and 7 a.m. And then we calculated day length using geosphere package in R. We removed outliers of sleep outcomes and temperature within each person. And because we expected nonlinearities in the relationships, we used GAMs, generalized additive models, to handle those. And also, we kind of repeated our analysis for each person. So we had a cohort level analysis where we had multiple measurements from different subjects. We put all that data into the same pool. But then as a second step, we looked at each individual person and ran that model for each person. So here are our results. On the left, you see our recruitment and enrollment chart. We screened 65 individuals above the age of 65. And at the end of 50, we had enough data from 50 subjects to include them in our analysis. Um, and on average, we had about 300 nights of data from each of these people. Slightly less than that, actually. So on the right, you see kind of our table one, characteristics of the subject, age. SPPB is a physical test that we did at the baseline, is a measure of their physical function at the baseline out of a maximum of 12. There is a high variation in our sample. And also, MOCA is a Montreal Cognitive Assessment, is a measure of cognitive function at the baseline. These are important things that we wanted to adjust for. Comorbidity index is a Carlson comorbidity index, which is a measure of health status at the baseline. And again, as you can see, the standard deviation of these metrics is actually quite high, meaning that our sample was rather diverse in terms of physical and cognitive function and also health at the baseline. Just pause here for a second for you to see the rest of the table. Um, this is the nighttime ambient temperature on the y-axis, and each box is one participant. As you can see here, um, we observed quite large variations in both within in temperature, both within each individual. So each box is an individual. There are people who were exposed to very different nighttime ambient temperatures over time, and also between different people. The kind of there is a quite large variation and difference between people. And interestingly, we observed the same for our outcome, which was the primary outcome, which was sleep efficiency. Again, it's a percentage. And as you can see here, people varied quite a lot between nights and also between subjects. This is our table two. There are too many numbers here. You don't really need to pay attention to all of them right now. But the point of this table is to show you the kind of the beta coefficient of our regression, the standard, statistical significance, and also the partial R squared, which is a measure of how important each variable was in explaining the variance in our outcome. And for the first three variables, because we use GAMs, we do not have beta coefficients because they were nonlinear. I'll show you their impact graphically in the next slide. The kind of takeaway from this table is that nighttime ambient temperature had a relationship with all three sleep outcomes, so total sleep time, efficiency, and restlessness of sleep. And the partial R squared were actually substantial, we think, meaning that it was a quite important variable when we are trying to explain the variability in sleep between and within persons. This is how, as I said, we use GAM, so nonlinear relationships, and this is how they looked. On the left, you see total sleep time, the vertical axis. And the middle panel is sleep efficiency, our primary outcome, and sleep restlessness. And the horizontal axis in all of them is nighttime ambient temperature. And as you can see, there is some sort of a U-shape relationship where sleep seems to be optimal within a specific range. And again, this is when we look at the entire cohort at the same time, so data from all of our subjects. We then looked at the between person difference in the relationships between sleep outcomes and temperature. And it was quite interesting because again, so the nighttime ambient temperature is the horizontal axis in all of them. Sleep efficiency is the vertical axis, the health outcome in all of them, and each panel shows one participant. So each participant has a panel here. And as you can see, at least within this range that we are showing here, and we had enough data from all the subjects to kind of to represent here, there is variation in not only the magnitude of the effect, but also in its direction. So meaning that temperature influenced sleep in each person in a kind of a unique way, even though we had that kind of overall trend, overall inverse U-shaped relationships that I showed you the previous slide. So summary of findings. even within a sample of older adults with a relatively high standard of living. So we had 14 subjects out of 15 who lived in subsidized housing. So there was some variation and diversity in terms of socioeconomic status, but even those subjects had quite a high standard of living compared to the kind of the overall population in the Boston area, overall older adult population. So even though that was the case in our sample, we still were able to observe that relationship that we hypothesized between nighttime ambient temperature and outcomes related to sleep. In particular, total sleep time, sleep efficiency, and restlessness, which was the number of movements per hour of sleep. And then we also observed substantial between subject variation in the relationship between ambient temperature and outcomes related to sleep. So the clinical relevance of this, just to give you a sense, because you saw some numbers on the vertical axis, like sleep efficiency, for example, the model predicted sleep efficiency dropped by about 5 to 10 degrees percentage as the temperature increased from 25 to 30 degrees centigrade. So what does that mean? Like, what does that translate to? So based on previous research, we can say that that would have an impact on next day activity, next day stress, uh, glucose management in the morning, anxiety, mood, fatigue, cardiovascular health, and it's the same impact in terms of size as the impact of alcohol or nicotine consumption, pain, energy expenditure, and daytime stress. So it seems to be quite important. And then the implications of this. Um, First of all, there's an opportunity to intervene upon the ambient environment in order to improve sleep in the older adult population. It's important from a climate adaptation point of view, as most cities in the US and across the world are getting warmer due to a combination of climate change and urban induced warming. However, we have to recognize that there's probably not a one size fits all approach that works for everyone because of those between subject variability. Um, Limitations and strength. Again, our participants had a relatively high socioeconomic status. However, this was one of the, not one of the first study to the best of our knowledge that had so much data from so many older adults. And these are objective measurements of temperature and sleep. We collected 11,000 person nights of sleep data. So those kind of regression analysis that I showed you came from that. And then our sample had quite a wide range of cognitive and physical function at baseline, and we did not exclude individuals based on their ability to use technology, which again is kind of unique to this study because that's not the case that has not been the case previously. Thank you so much for your attention, and I'm happy to answer questions.